Good evening, dear past presidents, council members, members of the ISL, invitees and ISL staff members. You all are welcome to Engineer Professor R.H. Paul Memorial Oration. Can you kindly rise up for presidential procession, please? Our first item today is lighting the oil lamp. I cordially invite the following dignitaries to light the oil lamp. Engineer Dr. Kamal Laksiri, President of the ISL. Two senior most past presidents, Engineer B.R. Fernando and Engineer Professor Lakshman Ratnayaka. Our immediate past president, Engineer K.P.I. Yudharmapala. Engineer Professor Udayanga Hemapala, our speaker today, a family member of Engineer Professor R.H. Paul, Engineer Chamil Ledirmuni, Electrical, Electronics and Telecommunication Engineer Sectional Committee Chairman, and Engineer Neela Besek, Chief Executive Officer of ISL. Kindly remain standing. Now our next item is garland in the portrait of late Engineer Professor R.H. Paul. I kindly invite President to garland the. Thank you very much. Kindly be seated. Now I invite following dignitaries to the stage. Engineer Dr. Kamal Laksiri, President of ISL. Engineer Professor Udayanga Hemapala, our speaker today. And Engineer Chamil Ledirmuni, the Sectional Committee Chairman of Electrical, Electronics and Telecommunication Engineering. Thank you. Now the first item of today is the welcome address. I cordially invite the President Dr. Kamal Laksiri to give away the welcome speech. What is it?
Good evening to all of you. Today we have gathered here to attend one of the important events in the ISL calendar, that is the Professor R.H. Paul Memorial Lecture. It's my pleasure to welcome all of you on behalf of ISL who are attending today on this Professor R.H. Paul Memorial Lecture. First, let me start our resource person today, Engineer Professor Udayanga Hemapala, Dean, Faculty of Engineering, University of Moratuwa. In fact, it's a very special day. It's his birthday. It's a coincidence. Actually, we got to know it late, otherwise we could have celebrated that. Then now the family members of the relatives of late Professor R.H. Paul, other invitees, past presidents, council members, members of the ISL, and Engineer Tamil Edrimuni, the chairman of the Electrical, Electronics and Telecommunication Engineering Sectional Committee, Engineer Neil Abhisekara, Chief Executive Officer, and the Engineer R.B. Gunadana, Deputy Executive Secretary of the ISL, and all the staff members of ISL, ladies and gentlemen. When we take a close look at the roots of engineering education in Sri Lanka, it has taken quite a challenging path to be where we are now. In this journey, there have been many engineering giants whom we can consider as pillars of Sri Lankan engineering education. Among such memorable persons, today we commemorate such a great character whom we cannot forget and known as the father of electrical engineering education in Sri Lanka, who is none other than one of our past presidents, Engineer Professor R.H. Paul. Professor Robert Hoinston Paul was born on 9th February 1904, exactly 119 years ago, in a fine day like today, and had his early education at the Anglo-Chinese School in Singapore and late at St. Thomas's College, Mount Lavinia. He passed the junior and senior Cambridge examinations and the London matriculation examination with first class division and won a scholarship to the University College, Colombo, the forerunner of the University of Ceylon. He was an extraordinary bright student who received his BSc General degree from University of London with first class honours through the University College, Colombo at the age of 20. He was awarded the Kumaraswamy Physics Prize and a Ceylon Government Engineering Scholarship for studies in the United Kingdom. He entered Trinity College, Cambridge in 1928 and obtained the Mechanical Sciences Tripos with first class honours. He was the first Sri Lankan to achieve this distinction. On his return to Sri Lanka in 1930, he was appointed as a lecturer at the Ceylon Technical College, Colombo, the only institution providing engineering courses at that time. The development of the higher level electrical engineering courses and the laboratory facilities at this college were largely due to his efforts. No doubt, much credit for the eventual recognition of the college in 1942 by the University of London to prepare students for its BSc Engineering external degree should go to him. He was then appointed as the first professor of electrical engineering, and from 1944 to 1949 he held that position, the post of director of the college. When the University of Ceylon established its Faculty of Engineering in 1950, Professor Paul was a natural choice as its first professor of electrical engineering. He held this position until his retirement in 1968. His natural interest in upholding the status of engineering profession in the country and all his efforts in realizing the same was well recognized and adored when the Institution of Engineers Sri Lanka elected him as a president in 1968. He was a fellow of the Institution of Electrical Engineers, IEE, London at that time, and now it's the IET, and also the overseas representative in Sri Lanka of this institution from 1964 to 1978, the first Sri Lankan to hold this position. He passed away on 3rd July 1978 at the age of 74, when the University of Peradeniya began holding its convocation after a lapse of about 10 years. The degree of Doctor of Science was conferred on him posthumously in 1980. a man of great ability, initiatives and drives, Professor Paul has made a lasting impact in the development of electrical engineering education in this country. ISL, being the premier professional body of engineers in Sri Lanka, we are so grateful to him by way of organizing this oration on his 119th birthday. So with that introduction, let me conclude my speech and continue with the proceedings of the event today. Thank you very much.
Thank you very much, President. Now, let me introduce our speaker today, Engineer Professor Udayanga Hempala. It's a very short introduction, in fact. Engineer Professor Udayanga Hempala graduated in year 2004, the first class honors in BSc in engineering, specialized in electrical engineering. He obtained his PhD from the University of Genova, Italy in year 2009. He was promoted to the post of professor in the Department of Electrical Engineering in year 2017 and served as the head of the Department of Electrical Engineering. Currently, he serves as the Dean of the Faculty of Engineering. He has been a council member of the ISL since 2018-2019 session. During the session 2021-22, he was the honorary secretary to the ISL Council. The podium is over to you, sir.
Dr. Laksiri, ISL President and past President of ISL and Council members and Chairman Electrical and Electronic Sectional Committee and CEO Engineer Neil and all other engineers of the ISL as well as the colleagues, my colleagues in the ISL as well as the Council. And first of all, I would like to thank Engineer Chamil for inviting me, and it's an honor to me because I'm addressing and giving the oration in this great occasion. Thank you very much for inviting me. And I'm Udayanga Hempala, and I'm not going to talk about any research or any some technical things, but I will try my best to deliver some important aspects of engineering as well as engineering education, and just for thought, and you can think about it even if you go from here and come up with some ideas and for the development of this country. And please don't take, I'm not going to blaming because if you just look at that brief of that flyer, I have seen because it says you should not blame anybody, right? And normally in my life also, I don't blame anybody, right? But I will try my best, and even don't blame to any system, but try to use the system to do something for this country. And that's why I try to use this title, The Role of Electrical Engineers for the Sustainable Development in Sri Lanka and the Way Forward. Right, the content, I will try to explain who is an electrical engineer and what is sustainable or stable or equitable society, because we are serving to this society. And then as electrical engineers, we are always looking about the electrical grid, what will be our future electrical grid. And once we take our future electrical grid, then we need to think of, as academics as well, we have to think about the engineering education and what we need to change and how we can go forward. And finally, the way forward for the as academics as well as engineers. Before going to discuss about electrical engineer, I thought that it's better to start from the basic definition given by all of us knows this IEA, that is International Engineering Alliance, that is all of us are now within that framework, because you are, even though sometimes we have may not studied any Washington Accord or Sydney Accord or Dublin Accord degrees or diplomas, but now almost all of us, maybe in future or maybe currently the IP, that is professional engineer, then you are anyway inside that circle, IEA circle. Therefore, it's better to know what are those definitions and how to use that definition without making any complex situation within the country. If you just look at these 3 accords, just to get some idea, Washington Accord is basically for the engineer, and Sydney Accord for the technologist, and Dublin Accord for the technicians. And who is an engineer? Because I'm not going to talk about other 2 because those are not coming under our purview. Identify, formulate, research, literature, and solve complex engineering problems. Now we need to think about whether we do actually solve, as engineers, whether we solve complex engineering problems. Maybe people can argue that we currently also we do these solving complex engineering problems, but we have to think that whether actually those problems are with the complex in nature of the engineering, or maybe complex because of something else. Sometimes if you try to figure out, actually it's not these problems are complex not because of engineering complex, maybe something else, maybe the management or something like that. Then if you just go in that way, then it's not coming under our purview. Sometimes maybe people can argue in future that kind of problems are coming under maybe the Sydney Accord, because those are not actually coming under the complex engineering problems. Maybe people may argue that okay, these are maybe broadly defined engineering problems like that. Therefore, as engineers, because currently in this institution we are having only engineers, maybe I don't know, in future maybe engineering technologies also may come, or maybe they may create their own institution. Now currently we are having double ISL created by diplomats, and they also claim sometimes we are engineers. Then engineering technologists also may claim that they are also engineers. Then what will we will be in trouble in future. Trouble means because if the engineering, actually if we are not doing complex engineering problem solving, then our students or our students or our graduate or our members will face difficulties, because they also have to find jobs in this market, and maybe if our market is not matured or our industry is not matured up to some extent, then people may argue that we don't need engineers sometimes, right? Therefore, we have to think twice, and we have to change our education, as well as we have to help the industry to come to up to some level where we can claim that we have a thing to do in that context as well. Then if you go with that, if you understand, okay, the electric engineer is some person who's doing solving complex engineering problems, then it comes to the electrical engineer. Then I just went through the internet and found some definitions. There are so many definitions given for this electrical engineer. Electrical engineers design, develop, test, and supervise. Now if you just look at that, design, develop, test, and supervise, everything together. Then if we try to now again go back and think about these accords, then somebody can say no, design is engineer, development, test is something like technologist, and supervise for the Dublin Accord. Therefore, there's a danger. My personal view is we should not try to define all these things as it is, because if you try to define everything, people can argue that okay, electrical engineer should do only design, development is somebody, and supervise is something, but that's totally wrong. If you go through the international definition, actually the design, develop, test, and supervise, everything is coming under engineer, right? Engineer should be able to do everything, right? Because if you don't know how to test, if you don't know how to supervise, you cannot say I am a Washington Accord graduate and I know only design, right? You cannot do that. You cannot say that. Therefore, we have to think about that as well. I mean, if you just look at our manuals, I mean, we have an ISL manuals are there. I mean, if you try to focus only those points given by IEA, we will be in trouble in future. Therefore, my personal view is we have to think about and think broadly and define these things to not to make any problems or many complex situation within these three categories. And then another definition I found, like electrical engineers are the innovators and designers. That's basically coming under the Washington Accord, that create these systems and keep them running smoothly, then working on everything from the nation's power grid to the microchips inside our cell phones, smartwatches and everything. That's, then again, it's everything. I mean, you cannot claim that you are only a designer. No, you should know how to develop. That is, I mean, just not only the research part or the design part, then you should know how to develop and then how to test and supervise everything. Right, then when it comes to the academic part of that, now we have one side we talk about who is engineer, then we need to make that engineer. In order to make that, we need to think about, we need to find out what is the difference or what is the gap between the academia and industry. Because curriculum of universities is more theory based rather than application based. This is just not my my personal things I just found from the internet, just for you to think, because these comments are not always correct for everywhere, right? I mean, it's these comments are basically general comments. Now, if you look at the curriculum of the universities, sometimes people blame that, okay, these are theory based, these are not application based. And when it comes to the technology, because now we are having technology faculties, and even they are, because if you look at the government point of view, these technology faculties came just to make people with some kind of application based and some skills based on the application, but finally they also end up with some theories, and because sometimes it may be due to our own issues, because the curriculums prepared by our own academics from the engineering faculties, and finally ended up with some theory based curriculums. And sometimes again people, our academics blame the industry as well, saying interns, because our students we are sending to industry, and they blame that interns not getting proper working environment in some companies. Right. And another comment is like faculties lacking industrial exposure, and I will discuss one by one then. And sometimes there is a gap between the examination and performance, because like we always measure the students' performance. Now, if you look at the outcome-based education and all these things, they are, but still we measure them based on the assignments, or maybe just most of the cases exam. Right? But if you look at the industry people always, industry's performance actually they measure their skills and everything based on the performance. There is a gap again. And again, skill or performance gap is there always, and as well as unrealistic expectation by the industry, it is always there, because we know, I mean, when we meet industry people for the DICB meet, its Department Industry Consultative Board, always they like sometimes they blame like they know theories but they don't know how to work something. Right? Likewise, unrealistic. Sometimes we may think that it is unrealistic expectation from the industry as well. Therefore, I mean, if you look at all these things, I mean, there is a responsibility for the industry as well as the responsibility of the academics. I mean, if we have to work together to make our graduates to suit the industry and to make our country the better country. Right. If I go one by one, like theory based and application based, now there are some concepts like how to measure the students' performance and how to deliver the contents. Now, if you look at, I've given some examples. Basically, PBL, that is a project based learning. now if you go through some other countries' curriculum, right, well-developed countries, they use project-based learning. That is one concept they use. They teach some little small amount of theory and ask the student to work on projects. That is basically they called as PBL, project-based learning. And another aspect, another side of that, I mean, these are two extreme things. And other side is design-based learning. That is basically our faculties, most of the cases we use design-based learning, and we give the students to examples or calculations. They have to do calculations, they have to do design, structural analysis, so maybe electrical case, maybe power system design, and these are basically design-based learning. But now, if you just look at the technologies, because our curriculum, if you just go through the technology curriculum, they are basically project-based learning, right? Not design-based, but I mean, as I explained, the curriculums, the different curriculums are there. But even if you go through our Sydney Accord accreditation manual as well, we try to include the project component over there, rather than putting design, assuming that engineers do design and they do project, something like that. But if you go through the curriculum in other countries, actually now they try to use some hybrid concepts like project-oriented design-based learning. They call it as PODBL. That is, they give a project and they have to complete the students. And like if you just take a power system module, they have to do a project, and within the project they have to do the design as well. They have to do the design and complete the project. They call it as project-oriented design-based learning. I think Sri Lanka also, we have to think about those. I mean, I'm just giving some example, but we have to study these concepts and try to use those concepts within our curriculum. Otherwise, our students will be in trouble, because our industry sometimes may expect in future only technology graduates, because they know how to do maybe a project. Because if the industry, the industry is not matured, they don't need much more design component, then they may think that okay, the best suitable people are technologists, not the engineering graduates. Then other one is interns not getting proper working environment in some companies. Actually, again, this is basically again some concepts people think about going for a startup rather than going to the corporate sector, like as an example telecom, CP, LECO, RD. I mean, these are corporate sector. Without going to the corporate sector, if you go to a startup, then you can learn more. Because if you go to the corporate sector, you cannot practice things, because they just ask you to maybe stay there, maybe they cannot give big project to you. But if you go to a startup, they will give project, because they trial and error. But if you go to the corporate sector, you cannot make trials there. Right. Therefore, primary purpose of short-term training programs, which are included in most of the higher education systems curriculum, is to extend the practical knowledge of the students. And many students opt to establish well-known companies, maybe due to so many reasons, like maybe payment sometimes, right? And they believe they will gain broader range of experience, because the corporate sector you can get experience, but not sometimes maybe not the technical, but maybe something else maybe. Currently, startups actually offer more scope for creativity and hands-on projects, and resulting in a more valuable practical education than that obtained from working at a large established company. But its pros and cons are there. But just to think like if we can offer, at least if even the corporate sector gives some projects to the students, actually really do something, right, rather than just going everywhere and just to see the places, just to get some only idea. Some cases we have seen, I mean, when we interview the students, they just have gone through the company, but they have not actually done anything. The other thing is basically the faculties lacking industrial exposure. That is a big issue in our faculties actually. because it's maybe it's not much correct if you just take the University of Moratuwa, maybe Peradeniya, the bigger faculties maybe, but if you just look at the faculties like Southeastern, Jaffna, that is a big problem because they don't have any opportunities there because industries are not there. And faculties across the board fail to provide students with the necessary skills for success in real world situations, because if you are a teacher you have to use real world examples. If you are not actually practicing as an engineer, or even if you have not done that, then the big question is how to teach the students. Now even we have some examples like some engineering faculties recruited even non-engineering people, right, to teach engineering subjects. They don't have at least the membership of ISL, because at least to go to the industry, we at least check whether you have the associate membership. But in the faculties, we don't look at. We just look at whether you have done the research or MPhil or a PhD. And many professors prioritize research or practical application. That is another one, because always people are looking their promotions, and we do research and get the promotions, and not the basically application side. I mean, it's not correct for everywhere. I'm just giving examples for even now our faculties as well. We have seen that, but the department like civil engineering, maybe it's different because they have a lot of opportunities. But if you go to the other sector, maybe it's not like if you take even electrical department. Now we have people, I mean, with lack of exposure to the industry, but they do research, but actually the industrial exposure is not there. It's not a big problem of the academic, actually. It's I mean, industry also think about that. I mean, because if they are not giving any projects or giving any opportunities to the academics, then they cannot work on the industry. I mean, we have to look at the both sides. It is crucial for professors to demonstrate the student how to monetize their research to better prepare them for the realities of the marketplaces. Now, how do we address this issue? Now, I have discussed some issues. One thing is to facilitate more interaction between faculty and industry, faculty members and industry, by maybe positions for R&D, especially for academics. Now, if you look at the other foreign countries, we have, right? I mean, if you are a professor, you can go to industry and work 1 year. I mean, we have the opportunity in here, like sabbatical leave and all these things are there, but those are not materialized. Like currently what we do actually, if you have a sabbatical leave, we go to maybe a private university or to get some, we can get a higher salary, but we will not get the actual the exposure to the industry, or will not get the actual experience, because even if you stay in the university, you do the teaching, and if you go to some other university locally, you do the same thing. But if you go to foreign country, maybe you can do research, maybe even teaching at a foreign university, you get some different exposure, at least. But now what this is as a tradition now, most of like maybe more than 70%, 80% academics, they don't go out of the country and they just go to some private university and do that. I'm blaming them, but that's the reality. Right? And projects with involvement of universities, basically like development project, research project, if we can start, like at least if the industry can collaborate with the universities for development projects or research projects, then at least they can contribute. I mean, the faculties can work with the industry and at least get some exposure. Then I'll go to some different side, just to show some examples. Actually, I have to thank Lanka Electricity Company, LECO, one of the distribution licensing current in Sri Lanka. Actually, the LECO and actually ADB funded this project, and the project came to LECO, and then they selected the university and developed a research lab. And it's not just basically just a research lab, it's basically industry funded research lab, because every year now from the LECO we are getting around more than 9 million I think it's almost around 9 million rupees for this research lab. That means we get every year, because these are that money is coming from the generation of the solar, because the solar, I mean, this system is owned by the LECO, and they generate electricity, and they calculate that amount and they give it as a research fund to the university every year. That means this is not like a basic lab, it's a funded lab every year, and then using that we can recruit research assistants or start projects, because there is a fund. Otherwise what will happen, most of the cases, our university, we get labs, but after 1 or 2 years we don't have any funds, because we have to ask fund from the government won't give funding for research now, even now, even the future. In the past they gave only a very small amount, but with the support of the ADB and the Lanka Electricity Company, we use that. I mean, this is a very good example for in future for the other industries as well, maybe the CB or any other companies, because if you have a lab this kind of lab, this is not for basically undergraduate work, because this is for project based lab, and the fund is coming actually for not for the undergraduate teaching, and for the basically R&D part, that is research and development. And every year we have to show that how many, what are the outcomes, and based on the outcome we get the funds for the next year. I mean, this will be a good example for industry faculty collaborations, and good example to go forward. And with that, actually there's just another example, because of that lab, actually we started the electrical department, we started a startup, that is the first startup from the electrical department actually. And we actually made solar inverters, and also now we are repairing inverters as well, because there are so many inverters companies who just sold their inverters, and after that you couldn't even find out the company. Then the customers are facing a lot of difficulties. Therefore, I mean, this is good example to show that, I mean, if the industry fund into the universities to come up with some labs, then using the lab we can develop some things and go to the industry, right? And even there are so many issues, like because there is no support sometimes from the government, but at least the industry academic collaboration is there. And actually from that, again from the same development from the ADB and the LECO fund project, then we started some other project as well. The CB also started funding. I mean, it's very difficult, we know, I mean, government university, government institution to fund to universities sometimes, but I thank the CB also started funding for this lab, and they funded 2 research assistants. And then again we started some projects with the ADB. This is just we submitted the proposal, and the LECO submitted proposal, and then it's approved by the ADB, and another technical assistance coming for AI powered microgrid pilot project. And this is just an example. Now we are going to develop it to a practical implementation of a selected area, and it's not just a small microgrid, it's an AI powered microgrid. That is, we use the artificial intelligence over there, and we are making an energy market in a small area, and it's also funded by the ADB. And right, then when it comes to the other gaps between these the academic and the industry, as I explained, examination versus performance problems are there, and skill or performance gap, and finally unrealistic expectation by the industry, because as I explained, students have high expectation from the industry, like maybe the salary, positions and timing. Additionally, many students believe that obtaining a degree is sufficient to secure employment. That is the biggest issue, because now always most of, like if you take more than maybe 80% students are coming to the universities sometimes, not even undergraduate, like postgraduate level, it's worse sometimes because they coming to get the certificate because they can claim 10% or 20% salary hike, salary increase from the industry if you have MSc. Then they come actually not to study sometimes, just to get the certificate. And that's, as I explained now, we are having like undergraduate courses, we are having postgraduate courses, we always teach the students, but student motivations as well, I mean, maybe the industry motivation is different and the student motivation is different. They just come to the industry, maybe they look at always salary, and if they don't, I mean, if they are not satisfied with the salary, they just change the job and go to some other company, or maybe nowadays they migrate. Now fine, but we teach them sustainable and all these concepts, but nothing will happen to the country and they migrate. Now if you just look at the sustainable development versus engineers, now electrical engineers are expected to take on a leadership role in the sustainable development. Sri Lanka overcoming the economic, technical and social challenge. Now if we just, I think if you have almost all of us maybe pass our B paper and we studied what is economic, technical, social challenges and what is sustainable, and all these things we study. But the problem is these are not in really we cannot see that sometimes. Government and professional institutions are responsible for making proper policies, because we don't have policies for development of the, I mean, we don't have policies for the development of the country, but at least even in the academic level or the institution level, we don't have any proper policies, because when a government change, always policies change, and even sometimes when the vice chancellor change, sometimes even in the institution level also policies change sometimes. Now if you look at why do we need policies, because we need to look at, I mean, getting the numbers right, because the demand and supply of engineers now, even I don't know, I mean, if you just ask our chairman and the sectional committee how many electrical engineers are in, I mean, if they are registered in the ISL, we know that, right, only from that, but we don't know how many engineers need for this country. I mean, electrical engineers need for this country, we don't know, right? And if you go to the UGC or the education policy level people, if they say, you know, we need more engineers, but we don't have any statistic, right? Because of that, even we cannot blame even the government making producing more than enough engineers or less or higher, we don't know, right? Then other thing is getting the skill right, because the quality of engineers, it is also a problem, because if you go to the UGC, they may say now, okay, we are producing this much of engineers and this much of technologies. They don't know how much ratio needed, right, for the industry, whether we are making them right or not, no one knows, right? And I think we started at the ISL level to do some surveying sometimes back, but we couldn't finish. But at least I asked the chairman sectional committee, at least if we can start with this to look at that, please, the electrical engineers or the electrical and electronic engineers, how many engineers need for this country, because my personal think or understanding is now we don't need much electrical engineers now. Electrical, I am talking about the power engineers, right? Because our power network is almost developed now, right? We have to thank all our senior engineers, they did a great job, and now it's almost developed. Right now anymore, it's not an electrical thing, and it's basically IT with electrical. Therefore, just producing just a power engineers, or whether we need to look at power engineers, power with IT and electronics, because you cannot develop our power sector just having knowledge of the power system subjects or the electrical machines in future. And just to give some idea about that, because our conventional power system, currently we are having these centralized generations, and generation follows load and one directional power flow, and we have limited automations, consumers lack data, and because of that we are having so many blackouts, right? Because we came to a point where it's matured and developed up to some extent where we cannot control now, because it's almost developed but without having using much IT. Because of that now we don't have the controllability, right? Because of that now actually we get blames, like, because our politicians always blame that engineers, they have not done the job, but it's not the case, right? I mean, we did our job, but the problem is maybe it's problem of our university side as well, because we produce electrical engineers maybe without knowledge of the IT sometimes, right? And they think about the knowledge and they develop the power network, but if you look at if you want to go to the smart grid or our development of the power network with IT, you need more IT skills now, because if you want to include or absorb more and more renewable energy, that is basically centralized with distributed generations, though as all of us know that I mean, these are variable resources. I mean, you cannot have any variable thing without knowing, because if it is a constant or a stable thing, everyone knows what is happening. But if it is a variable thing, if you don't know the idea or if you don't know what is happening over there, you cannot control, right? Then consumers become producers, that is prosumers, and multi-directional power flow, and the loads are flexible, and people are talking about adaptive islanding, or maybe restore automatically the network when the outage occurs. I mean, all these things are part of this future power grid, but problem is when we can have this future power grid. Always because if you take these smart grid discussions, maybe 2000, somewhere around 2000, maybe 20 years ago, people discuss. Even I know, I mean, CB as like a roadmap for the smart grid roadmap. But still, we are here in the conventional power grid. I think the problem, there are so many issues, I am not going to talk about that, but at least our side, or our, as academics, what we need to do is we have to give the knowledge to the electrical engineers with the IT skills or the IT knowledge to the electrical engineers, otherwise they will be in trouble in future. And I'm not going to discuss the what is smart grid, but I think almost all of us know that. But the important thing is the IT, like two-way digital communication is a must, right? And that means you need to know communication. Then when it comes to the smart meter, I mean, just buying a smart meter and install a smart meter, I mean, it's everyone can do that. But as engineers, we should think about beyond that, because making like assume you get a loan from ADB or maybe somewhere World Bank or somewhere IMF, or you install 1,000 smart meters somewhere. I think already CB has done and LUCO has done. But I mean, if you don't use that, and if you don't practice or if you don't use the data coming from there and use it for your future activities, I mean, it's the investment is basically waste, right? I mean, therefore, I mean, if you go with some development, you need to understand how you are going to use them, and you should have some roadmap and use them in a proper manner to make it sustainable. Otherwise, I mean, just putting something, and if you don't use it after some 1 year, 2 year, then you will be in trouble, because then again after 1 or 2 years, if something happened to the smart meter, then you have to remove that smart meter and again buy a smart meter from China or somewhere, right? But I know, I mean, the smart meters we have developed, even CB R&D branch, they develop a smart meter, and universities has developed, but we don't use those, but we just bought smart meters some other China or somewhere and just install them. And right now, if you look at these smart grid concepts, as like a smart meter is just a one thing, that is an advanced metering infrastructure, but it is just, that's I explained, like just putting a smart meter is nothing else. Like I mean, it's not anything. I mean, anyone can do that, but use those data and do some kind of things like demand response, right? I don't know whether we have not practiced or we have not tried to do demand response. Maybe there are so many policy papers, maybe publications with the demand response, but we have not even touched that. I mean, I'm talking about the practical applications. Then even distributed energy resources with the storages or electric vehicles or distributed grid management, and all these things are like this. Smart grid is basically you cannot do it. My personal view is you cannot convert your conventional power grid maybe with by investing or by putting money. You cannot make a smart grid. Actually, you have to, we can buy maybe some of the electronic components, maybe a smart meter or some other components, but our engineers should be able to use them and use them for the future development, right? Now, as an example, demand response. In order to develop a demand response program, you need a smart meter. You can buy a smart meter from somewhere, but the DR program should be developed by ourselves. Now, what is happening sometimes, you put a smart meter one time, and after 2-3 years you think about the demand response, then again you go to ADB or somewhere and find out again loan, and then put in another demand response program. Maybe now at the moment now all the smart meters are not working, then you have to we are using some other place. I don't know, this is a problem of our management, right? It's not actually sometimes I'm not blaming the electrical engineers sometimes. It's not the problem of the electrical engineers only. It's the whole system, right? And maybe the whole government sector problem, right? And as I explained now, yes, the grid is smart because you are using intelligent technologies. Therefore, in order to do Internet of Things plays crucial role in functioning smart grid. Now, and it establishes a communication network and the two-way communications, then smart meters, data concentrators, communication channels, then web servers. Now, if you look at all these things, actually, it's not power engineering. Actually, it's basically IT. But we should understand again, if you just hire an IT guy, you cannot do that as well, because IT guy they don't know the basics of power system or how to work the power system. What we need to do is actually we have to build up these knowledge within our graduates. Otherwise, we'll be in trouble. There are some problems. Like again, if I can take examples from my own university, my faculty. Like now, we are having electrical department, we are having electronic department, then we are having computer department. 3 departments. And electrical department we teach power systems, and electronic people teach electronic things, and computer people teach IT thing. Now, if you try to teach IT within now, then they that no, you cannot teach. It's our subject, right? Even within even our faculties, these are the problems, right? But if you come to the industry, you cannot find out these are. This is an embedded thing, right? You have to teach everything together. And if you go to the foreign universities, mostly you can find like the department like electrical and electronic, or electrical and computer systems, electrical and information systems, because you cannot work alone and saying like I know only this part, right? You have to know all the other subjects as well in order to work in the industry like this this kind of industry. That is the biggest problem even we are facing within the faculties. And as I explained, demand response programs basically enhance reliability. But in order to do that, again, it's just not only the technical thing, because there are 2 aspects, the technical aspects as well as the commercial aspects. Because if you just ask because now we know always people, the CB or the government asking, okay, switch off lights or whatever. but we don't do that. Why we don't do? Because if you have money and if you are paying electricity and if you have enough money to pay the electricity, then why do you have to worry, right? Because it's my money, and I can then it's the responsibility of the CB to give the electricity to me because I am ready to pay, right? That's the problem. But people are asking, no, don't switch off this light and don't use air conditioning during these peak times. But no one answering that, right? I mean, no one doing any change to your life because unless it's coming to your problem for your pocket, right? Therefore, we need to think about, even if you come up with these programs, you have to connect that programs into some kind of a tariff. Otherwise, no one will change. And if you go to other countries, actually, there are, right, like there are price-based demand response programs or incentive-based demand response programs. That means, like, if you, without using your, assume you have a washing machine, if you can, without switch on during the peak time, if you can start the washing machine in the morning, then you will get the incentive. Otherwise, asking, okay, don't use in the peak and use the daytime, no one, right? Why do you have to change my life because of, without getting anything, right? Therefore, we need to give something for the customers, otherwise customers won't change. Therefore, this smart grid concepts or smart grid technology will help the utilities to get some benefit, but you need to, just only the technical aspects will not happen. You have to use commercial aspects as well and change some kind of, giving some incentives or something like price-based things like we have in the time of day tariff or what kind of, some kind of thing we need to include. Otherwise, people won't change their life because of this request. Another thing is wide area situational awareness. That is, we should know, people are always talking about like 70% renewable energy, 80% or 90%, 60%. And I can say personally, I like to have 100% renewable energy. But the problem is, having 100% renewable energy is good, but you should know what is happening in the system. Then in order to do that, you should understand that is we call as wide area situational awareness. We should know, right? In order to know that, some kind of sensors should be there, some instruments should be there, then everything should come to your computer, and then you can understand what is happening in the system. Otherwise, just asking like going for 100% renewable energy, that means it's become a big issue to the control center or the system control center to control the network. And then as I explained, like electrical engineers worldwide, people discussing these things. Still we are talking about how to purchasing coal or how to purchasing diesel and all these things. But the other countries, people are discussing about energy internet or that kind of new concepts, right? It's a smart, responsive, decentralized network of energy and information that would help to eliminate energy poverty. That is the term we use, energy internet, because everything is connected through the internet, right? And it's not like, that's why I call, we cannot go ahead with just only with the power engineers, we cannot go ahead. We have to work with the communications, electronic engineers, computer engineers, because if you want to make a market, right, energy market, you need all these things, right? Engineers must acquire more IT and communication skills and actively participate in research and development to proactively provide solutions. Otherwise, we cannot come up with these issues. Always we can discuss these things, nothing will happen. And just right. Finally, I think we are talking about energy crisis, dollar crisis, but as well as I have seen, this is sometimes back, I think minister told sometimes they around per month we need 100 USD something for uninterrupted power supply or something. Assuming it's correct, I don't know whether it's correct or not, but the problem is that now just giving uninterrupted power supply, for what purpose? I mean, we need to understand for what purpose. Just to watch TV or just to switch on your AC? I mean, do we need to invest this much of foreign money? I mean, if you have foreign money, there is no issue. But if you are, when you are in a crisis, whether do we need? But the problem is, as our system is a centralized network, you cannot do that, because you cannot identify who are the people needs this, like industries or maybe the hospitals. You cannot identify. Then what you need to do is you just cut off. Maybe you have to cut off, or you have to give the electricity without any load shedding. Now we do that, right? I mean, even hotel sector, we know. I mean, some areas they don't cut the electricity, but if you are lucky, if your house is nearby a hotel, right, or if your house is nearby a hospital, you are again lucky, right? I mean, these are the problems in our country, right? Now, are we investing this money only for economic development or to improve living standards? I mean, we have to think about that, right? And can we increase the RE penetration or renewable energy penetration just by promoting rooftop? That is now our policy makers, they do just get this percentage by promoting rooftop. Is it possible? For me, it's not possible. I mean, you have to go with renewable energy plus storage, because these renewable energies are intermittency. But with minimum investment, because now we don't have much, we don't have money. Therefore, we have to think about, as engineers, how to use the money we have to give at least for the economic development, at least for the industries. Then just one solution for that is basically a microgrid concepts. That is, we just identify some important clusters and make them as microgrid. Then at least then they can be sustainable, even or they can be sustainable without any impact from the grid. And there are so many different types of microgrids available in other countries. Like you can have remote microgrids, like in Sri Lanka also, I think Veluvathu area, in the Jaffna area, we have one remote microgrid. And even utility microgrids, community microgrids, like sustain, we can make in other countries I have seen, like they make sustainable community. That is, that community is based on they get the electricity from the microgrids, and there are industries also within that cluster, and it's a sustainable community. And like as I explained, I mean, the sustainable community microgrid is a very good example, and I have seen in the Philippines. I visited sometimes ago, sometimes back, sustainable microgrid, and they are actually that community is sustainable, and they don't depend much about from the other places. I mean, they develop whatever they want within the community. And another sector is basically tourism, because as I explained, we have faced we've been facing a lot of difficulties giving electricity to tourism. But now the ADB came up with some grant. It's like a grant, and for development of microgrids for tourism sectors. And as well as commercial and industrial microgrids, there is another area where we can develop, but again the problem is whether it is sustainable, because investment is somewhat higher sometimes, return is low. Then people as the industry, they don't go for investment. Then we have to find out donors sometimes, right? Finally, way forward, we need to promote some kind of concepts like microgrid and targeting customers who have critical and uninterruptible loads. I mean, we have to understand who are critical people, and we have to give the electricity for them for the development of the country, and promote microgrids or the renewable energy penetration with battery storage, because if you go without battery storage, you will be in trouble and you cannot control them. And again, you can promote maybe microgrid clusters with the microgrids are interconnected with the distribution network. and finally the government should come up with some financial incentives, otherwise industry will not invest money, because if the ROI is high. Right, and just to before wind up, again we started the universities because as we are now talking about the sustainable thing and everything to the students, we thought of we have to come up with some idea and show some examples to the students, and we started the project to connect 4 labs within the 4 universities, Moratuwa, Jaffna and Roon and Peradeniya, and connect in one network, and then the Peradeniya students can, without coming to Moratuwa, they can do some labs practical virtually, and then the government will ask funding for just for one university, then without repeating the same lab in the other universities, other university students can connect through the virtual systems and do the practicals, but maybe once in a year they can come physically to do some practicals, but most of the practicals they can do through virtual networks. That is one thing came up with some discussion with the universities, and finally, and this is another the dream of our. We started some discussions, and I think if we are going, our sector is going for renewable energy. We have to come up with some kind of ideas like this national energy renewable labs, because now what is happening is R&D. If you go to the PUCSL, they also do R&D. CB, they also do. LECO, they do. And universities, we have 6 engineering faculties, and all the engineering faculties, they do research, but nothing will, nothing coming out. They do what they can do, but it's not like a national outcome. There is no national outcome. Therefore, we actually proposed to the government, and we had a discussion with the ministry as well, and come up with NREL, that is, I think NREL from the US. It's a very good lab funded by the industry, and then the industry can, if the industry has any problems, they can give it to the lab and do research and come up with solutions. We have to work, my final request is, as academics and all of us are engineers, we have to, whether it is academics or industry, we have to work together and do something for this country and for the sustainable development of finally. Okay, thank you very much.
Thank you very much, Professor, for your highly informative speech. It's an eye-opener for all of us. The next item of the agenda is the presentation of a memento to our guest speaker. I cordially invite the President to hand it over to our guest speaker today, Professor Udayamihipal. Thank you very much, President. Now, the last item today is the vote of thanks. I cordially invite our sectional committee chairman, electrical, electronic and telecommunication engineering, Engineer Chamil Ediruni, to give away.
Thank you, Engineer Neil Abhesegara, who is the CEO of ESL, and ladies and gentlemen. I think this is one of the most memorial lectures I happen to attend, and also I think maybe for you as well, because coincidentally Professor R.H. Paul and Professor Udayan's birthdays are coincidentally matched. So that's the most memorial thing here with the lecture. Apart from his brilliant ideas and innovations, what could be the way forward for the electrical engineers that he has discussed. Anyway, there will be many more things that he will do to guide us, because in council also he had been closely relating to the IESL as well. He is not only taking care of the university, but also taking care of the IESL as well, because I know that we have been in the council for many years. And anyway, I came to know actually 1.5 hours ago that the birthdays are matched. So that please bear with me, because we have arranged a short celebration when we are going to the occasion of this fellowship and dinner. But I don't know whether it has been arranged. I think it could have been arranged. So this is very coincident. When we were working with the IESL, this sectional committee in 2022, this is my second term as the chairman. Actually, I invited Professor to do this lecture, but he told that no, Jamil, I'm not. So thank you for that, but let's invite some other prestigious lecturers and others, so that I will be taking in the future. So thank you very much for actually doing this in this time, 2022, 2023, and you are very humble, and but I think you will enable us with your knowledge, because you are also comparatively young, so that we are blessed with your teaching abilities and also the guidance for us, and I am sure that you will guide us for the betterment of the engineering fraternity. I must thank you in accepting this occasion and then delivering this wonderful speech. And also I must thank the family members of R.H. Paul, Professor R.H. Paul, the family members. I think they are not here because maybe all are out of the country. So thank you for your, because we have invited them, so that they told that they are out of the country. And the president of IESL, Dr. Kamal Laksiri, thank you very much for being with us and then guiding this memorial lecture. This is the first in this year. And also council members, thank you very much for attending this, and also past president, they are the pillars of the organization. Thank you very much. And Chief Executive Officer, Engineer Neil, and his staff, thank him for helping with us to arrange this memorial lecture. And the sectional committee, I must thank Deputy Chairman, Engineer Audana, and Secretary, Engineer Kosala, and also other committee members of the sectional committee. And we have invited some personals in the capacity of senior management of some organizations. Actually, thank you very much for coming with us in universities and also in CB. And so I must thank you all the participants who are gathered here in spite of this now the situation in the country. Thank you very much having some numbers here. So we will be remembering this, and also I take this opportunity to welcome you to the next memorial lecture, which will be scheduled in November. Mr. Vimal Surendra memorial lecture, we will be organizing that. Yes, I will be failing in my duties if I may not mention the staff of ISL and also the caterers who have been feeding us. Thank you very much. And then I must thank you all again, and please enjoy with us the fellowship and dinner which we are organizing for you. Come to the members lounge, and maybe we will celebrate the double birthdays as well. Thank you very much.